In this video, we will be doing the echelon inventory management scenario. This is from the supply chain inventory management topic. So we have a warehouse, and in this example, this warehouse supplies 3 stores in Fairview, Bristol, and Springfield. Each store has its own demand. So there's a small d's like the average level of demand. The standard deviation is the sigma because demand is variable. And the warehouse sees the sum of their demand. So D1 plus D2 plus D3 would give us the total demand at the warehouse. And then the standard deviation we can try to estimate using this formula. So in any case, what do we have to do? We know the lead time between any retail store and the warehouse is 4 working days. And then the warehouse has its own lead time of 10 working days because if the warehouse is out of stock, the warehouse has to order from the manufacturer. Daily demand for the working days in the past year is given in the Excel file for this question. So we have demand data given. We can calculate the averages and the standard deviations from that. Cycle service level is 98%. Okay, and we can compute the total demand at the warehouse and the standard deviation of the demand at the warehouse using these formula. So the first question is, what is the standard deviation of total demand for the warehouse using this formula? So we can download the data to begin. Okay, so first up, let's insert some rows here so we can compute our statistics. We can do it at the bottom as well, but I'm just going to do it at the table at the top. So we can find the average and standard deviation of the demand at each location. Okay, so the average daily demand at Fairview is 78.79. Okay, and I can just drag this formula here to get the average demand for the different locations. stdev.s, because it's a sample, we don't have all possible data for each location. So we get the standard deviation for Fairview is 21.14, and I can just drag it across. Okay, notice I'm not rounding off any of the answers. I'm just displaying 2 decimal places. Just makes it look neater, but all the decimal places are still there. So I'm not rounding off any intermediate calculations. Okay. Now once we have the D1, D2, D3, we can find the warehouse statistics, the total. So the warehouse average demand is the sum of the 3 demands, and the warehouse average standard deviation is the square root of the sum of the variances. So we add up variances. We do not add up standard deviations. So I have to square each standard deviation to get a variance. So this hat 2 means square that number. We square all 3 numbers, we add them up, and then we take the square root, and that's the standard deviation at the warehouse based on the formula given in the question. Okay, so part 1 is the standard deviation of demand using this formula to 3 decimal places. So it'll be 31.828. Okay, so we're going to put 31.828. What is the echelon reorder point for the store, the Fairview store? And then what is the echelon reorder point for the warehouse using the total demand statistics for the warehouse computed previously, which is this stuff right here. Yeah. So we need to find some reorder points. So let's do that. So for Fairview, it's easy to find a safety stock and then find the reorder point RP. Okay, for safety stock we need the z value, the z score, norm.s.inv 0.98 because cycle service level was 98%. We multiply the z score by sigma DLT, the standard deviation of demand during lead time. Now in this question, there's no standard deviation of the lead time given. So we're going to assume the lead time is fixed, because if we don't provide standard deviation for a quantity, that means the quantity is not varying. And so our lead time is fixed, demand is variable. So our formula is going to be standard deviation of demand multiplied by square root of lead time for sigma DLT, then times the z-score will give us the safety stock. If you do not know what I'm doing, let me just write it here. So safety stock will equal z times standard deviation of demand times square root of the lead time, L. Okay. If you don't know where this formula comes from, review the essentials of inventory management topic. Okay, because that topic covers, okay, how do you find for continuous review inventory systems when you're finding the reorder point, how do you find the safety stock, or how do you find first the standard deviation of demand during lead time, sigma DLT, and then use that to find the safety stock. So we take the z-score multiplied by standard deviation of demand multiplied by a square root of the lead time. I'm going to put lead time here, and so the lead time store to warehouse is 4 days. Okay, so that's my safety stock. Then reorder point is simply going to be D times L, the average demand times the lead time days plus the safety stock. Okay, now this reorder point is the echelon reorder point, because to find the echelon reorder point, we have a mechanism to do so. Okay, and you can see here that you need to find the echelon lead time and then use the echelon lead time in the reorder point formula. The good news is that for the retailer, the echelon lead time is simply the lead time. So let me show you the picture here. So you can see the echelon lead time for retailer is simply just the lead time for the retailer. Okay. And then the reorder point is simply D times echelon lead time plus Z times sigma DLT, where you use the echelon lead time instead of the lead time. So it's very similar to what we have done before, except you replace lead time by echelon lead time, and for the retailer, the last stage in the supply chain, it doesn't matter, it's the same thing. Echelon lead time is the lead time. Obviously for warehouse and manufacturer, the echelon lead time is not just the lead time, so for them the calculation is, the numbers become different. Okay, so that's the reorder point. So we've done this question. What is the echelon reorder point for the warehouse? So now for the warehouse, that's going to be interesting. For the warehouse, we first have to find the safety stock. So we take the z-score times the standard deviation of demand at the warehouse, which is this one calculated using the formula, times square root of the echelon lead time. So that's going to be this plus the lead time between the warehouse and its supplier. Okay, and I have to add that lead time warehouse to manufacturer, which is 10 days. Okay, and so that is a safety stock here. Okay, so now we can find the echelon reorder point. That's going to be the daily demand times the echelon lead time, which again is this plus this, plus the safety stock. Okay, so that would be the reorder point at the warehouse, 3,903. Now we will relax the independent demand assumption. Well, where will we make this assumption? In using this formula, the second formula here. This formula is only correct if the demand at the three stores is independent of each other, i.e. the Fairview store demand increasing does not influence Bristol. Bristol's demand going up or down does not influence Fairview. and the demands do not move in sync, so they are independent. This can be sometimes a little bit problematic in real life, because sometimes something, if their areas are close by and you don't find something in the closest location to you, it's not in Bristol, you just go to Fairview. Also, sometimes for especially nearby locations, the same factors could be affecting demand on more than one location, so demands could be correlated. So if demand is correlated, then this is not the right standard deviation to use. So how do we do that? Well, we have to make a total column in Excel. We have to empirically find the standard deviation. So we just make a warehouse column where the demand in each day is just the sum of the demands. Okay, and then we can find the mean and standard deviation of this total column to see what is happening. Okay, so I'm out of space. I'm going to move this stuff over here. Okay, and so this was formula based, and now I'm going to do what I call empirical demand at the warehouse, which is basically based on the actual demand data, not using the formula applying to the data of the stores. So let's look at actual demand the warehouse sees, which is this total. And so you'll notice that the average does not change. So the average demand stays the same, whether you use the formula or you use the empirical method of calculating the total column and computing the average. But the standard deviation is where we had the independence assumption. So let's see if this comes out to be the same. And no, it does not. Standard deviation is actually higher because the demand in the three regions is actually correlated. It's not independent. If it was independent, the standard deviation would be the same that you got from the formula. But if you calculate the warehouse total column and you use the statistics on this column, the average and the standard deviation, we find that the standard deviation of total demand or the warehouse demand is actually higher than what the formula suggests, because the three regions do not have independent demand. Okay, so standard deviation of demand at the warehouse is this one, 39.41 to 3 decimal places 407. Okay, next up, what is the echelon reorder point for the warehouse? Use the demand statistics computed using Excel. Do not require the independent demand assumptions. So we're going to use these statistics here to compute the echelon point at the warehouse. So we already did that. Well, we can just kind of do it again. Okay, so nothing in the lead time side changed. So safety stock will be the same. Let's do warehouse like part B. Okay, and then the safety stock part will stay the same, because it will not stay the same because the standard deviation has changed. So it depends on lead time, z-score, and standard deviation. This has changed, so we'll have to put in the formula again. We get z-score times this standard deviation, which is calculated using this total column, times square root of the lead time. This is because lead time is fixed and only demand is variable. If lead time was also variable, we'll have a more involved calculation, a little bit longer formula, which we did when we did the safety stock for the problem prior to this one, the regular problem about the hotel. So in this problem, we did the case where the lead time is variable, Gray-Wolf-Lodge scenario. Okay, so let's go back. So this is our safety stock calculation. Then to get our reorder point, we take the daily demand. That has not changed when we do the total column times the lead time plus the safety stock. And we see that the reorder point is also a little bit higher because of this increase in the safety stock. Why did the safety stock go up? Because the standard deviation is higher when you compute the total column for the warehouse. than it was when you just use that formula. And why is it higher? Because the three regions, the demand is not independent. One way to check that is just take a correlation. So let's take a correlation, correl, between, let's say, the first two columns. So this, and then you can do 1 and 3rd and see. You can check all the correlations and you'll realize that the correlations are not 0. So notice it's a 0.32 correlation between Fairview and Bristol. That's a moderate correlation. So these two are not independent. The demand in the two regions is not independent. And we can see that from the correlation, which is what's being captured here. So this is the better option. And then this is the not so good option. Okay. Because this one assumes demand is independent. Okay, so we have the reorder point for that. What is the estimate for the warehouse? We did that. Okay, why was the standard deviation of demand at the warehouse larger when we created a total demand column in Excel? What is the effect of this increase in real life? What you should do. So this standard deviation 39.4 is larger than the 131.8 using the formula because the demand in the three regions is not independent. And we can also see that from the correlation calculation that the demand is not independent. This increase in standard deviation increases safety stock, which in turn increases the reorder point. So that's the effect of that. In real life, if we have historical data, we can just create the total column easily here and compute the mean and standard deviation. We don't have to rely on a formula with some strong assumptions about independence. Okay, so that'll be the answers to question 8. So hopefully this was helpful. If something here does not make sense, you have to understand this, you first have to understand how to compute reorder point for just normal inventory management. And then when you go to the echelon, multi-echelon stuff, you basically just replace the standard deviation of demand during lead time by the appropriate numbers that are computed using the echelon lead time. And you also use the echelon lead time in all of your calculations.